Okay, everybody, we're going to go ahead and continue on Chapter 2. In this lesson, we're going to go ahead and work on solving linear equations. Last section, we worked on the addition property of equality, moving constant terms and variable terms from one side of the equation to the other. So we're going to build on that, and today we're going to learn how to use multiplication to get our variable all by itself. Like I said, last week we worked on the addition property. This week we're working on the multiplication property of equality. The same non-zero real number, so any number except for 0, that includes decimals and fractions and negative numbers, may multiply both sides of an equation without changing the equation's solution set. What that means, just like in the addition property, we can do anything we want to our equation as long as we do it to both sides equally. Okay, so let's go ahead and take a look at what we get. Many times we're going to have our variable in a fraction like this. It's 1/3 x is equal to 7, and we're going to be asked to solve for our variable. Well, this looks really tricky. It looks a lot different than anything we're used to. But remember, in this situation, x over 3, that just means 1/3 x. So 1/3 is a coefficient. We got to find a way to get rid of that 1/3. Well, the way we can get rid of 1/3 is by multiplying 1/3 by 3, because 3 times 1/3 is equal to 1. So then we just get a 1 in front of our x, and that's what we always want, right? So we got 3 times x over 3. The 3's cancel out, and you just get x. But if we multiply by 3 on one side, we have to multiply by 3 on the other side. So here we see, if we do that, the 3's cancel out, like I said, and we get x is equal to 21. And if we simplify, we know we don't need the 1 in front of the x. We get x is equal to 21. Now dividing both sides by the same non-zero number, we have to use this whenever we have a variable that is not a fraction. So sometimes we'll have a situation like this: 5x is equal to 20. Here the 5 is our coefficient. We need to get rid of it. We need to get a 1 right here where the x in front of the x, so we can get our solution. Well, this is the same thing as a multiplication, but we're using division. How can we get rid of that 5 right there? Well, we divide by 5. Okay, so we divide this guy by 5, because 5 divided by 5 is equal to 1, so we end up again with a 1 in front of our x. Well, if we divide by 5 on the left, remember the rule, we have to do the same thing to the right. So if we divide 20 by 5, we end up with 5 divided by 5 is 1, or just x, is equal to 20 divided by 5, which is equal to 4. And we've solved our solution. We solved our problem. Very similar thing like the very first example. Fractional coefficients. Remember, fractions are also just numbers. Treat them as just as numbers. We know how to work with whole numbers. Fractions are no different. So let's go ahead and look at a problem here. We have 2/3 w is equal to 8. W, of course, is our variable. We need to get a 1 right here where the 2/3 is at. Well, how do we get rid of 2/3? Well, we multiply by 3/2, or you could divide by 2/3. But division by 2/3 is essentially multiplying by 3/2. So if we multiply by 3/2, we know the 3 and the 3 cancel out here, the 2 and the 2 cancel out here, and we have just a 1. So now we have 1w on the left. But again, if we multiply by 3/2 on the left, we also have to do the exact same thing to the right. So multiply 8 times 3/2. And 8 times 3/2 is going to be equal, we know the 4, the 4 goes, or 2 goes into the 2 and the 8, and we're going to get a 4 up here, so 3 times 4 is equal to 12. And there's our answer. So here's an example using both properties of equality, the addition and the subtraction. And this leads into a little bit of what we're going to be doing next week, or in the next section, I'm sorry. We have the problem 3x minus 10 is equal to negative 4x plus 18. Well, just like we learned last time, we like to get all the variables on one side and all the constant terms on the other side. So here what we went ahead and did is we got all the x terms on the left and all the constant terms on the right. So if we want the x's on the left, we have to add 4x to this side, which we did, and gets rid of this. It cancels out here. But we also have to add 4x to this side. So then we combine like terms. 3x plus 4x is 7x. So we got the minus 10 on the left is equal to 18. Now we have to move the minus 10 to the right. So we have to add 10 to this, add 10 to this side. Now we get 7x is equal to 28. Now we have to get x all by itself. And the way we do it is just like we did before. We know we want a 1 in front of the x. So we divide both sides by 7. 7 divided by 7 is 1, so we've done it on the left. 28 divided by 7 is equal to 4. Now we have our solution. So here are some key steps. It might be good to print this particular slide out and keep handy. Excuse me. The first thing we always want to do is simplify the algebraic expression on each side. That means collect all your like terms and combine them as low as you possibly can. Then move everything that's a variable to one side and everything that's a constant to the other side. Then we say isolate the variable and solve. When we say isolate the variable, what we really are looking for is getting a 1 in front of that variable, just like we've been doing. The last step we haven't done yet, we'll show you how to do it next, is how to check the proposed solution in the original equation. So check your work. So especially when we're taking quizzes and exams, this is a really key step to make sure you've done your work right, and it's really simple. So this one says solve and check. So again, the first rule is we got to simplify the algebraic expression on each side. We simplify by collecting like terms. We see on the left we can combine the two x's. On the right we can combine the two constants. So when we combine that, we get 5 plus x, because negative 3x plus 4x is just positive 1x. And on this side, 1 plus 12 is 13 minus 7x. Now so we just combined like terms there. The next step is collect variables on one side and constant terms on the other. I would like to bring my constant terms to my right and my variable terms to my left. To get rid of my variable terms on my right, we add 7x to both sides. We add a 7 here, add a 7 here. That makes this 5 plus 8x is equal to 13. Now we move our constant terms from our left to our right. We have to, since this is a plus 5, we've got to subtract 5 there, subtract 5 there. And now we end up with 8x is equal to 8. That's good, because now we have no more terms to combine. We got our variable on our left and our constant on the right. Next step, we isolate the variable. Remember, we isolate the variable by getting a 1 in front of that x. And if we have 8x, the way we get a 1 there is by dividing by 8. We divide 8 by 8, that gives us a 1, so we get a 1x. But the golden rule of algebra, you can do anything you want if you do it to the other side as well. So the other side of the equal sign, we also have to divide by 8. And we end up with x is equal to 8 divided by 8, which is equal to 1. Now, this is a really, really cool thing about algebra. You can check your work. So we found out that x is equal to 1. Let's check to see if that works. So we go back to our original equation, not even simplified, but just our original equation, and we put in 1 everywhere we see an x. And we've done this before too in chapter 1. So just plug a 1 in there, 1 in here, and 1 right here, and we simplify. 5, and we know 3 times 1 is just 1, 4 times 1 is just 4, 7 times 1 is just 7. And now we have 5 minus 3 plus 4, and we're going to be checking to see if this is indeed a solution, if this is indeed true, that this side is equal to this side. We don't have to move anything, we just need to check the work. So here we say 5 minus 3 plus 4, that gives us 2 plus 4, because 5 minus 3 is 2, 2 plus 4 is 6. 1 minus 7 gives us negative 6 plus 12, it gives us 6. 6 is equal to 6, that means it's a solution, and we are done with this section. Good luck with the homework, and have a good week.